Okay, now you're asked to find the point or points at which a graph has a horizontal tangent line. So what that means, let's just say that, I'll just do a sketch. Let's say that this is our graph here. Okay. This point would be a point that would have a horizontal tangent line. Okay, so this is what we're looking for, is this type of situation. So what you've got to keep in mind is that if it's a horizontal line, that the slope of a horizontal line is always going to be 0. You've got to keep that in mind when you're working these. All right, so the first one is the y equal x squared plus 1. So since we're, talking about a tangent line, we know that this tangent line is going to have a slope of 0. That means we've got to do derivative. So my derivative would just simply be 2x. Of course, the 2x is the derivative of the x squared. Derivative of 1 is 0. Now, like I said, if it's a horizontal line, the slope has to be 0. If you remember, a derivative is the slope of the tangent line. So like this expression could be used to find the slope of any tangent line on this curve, but we specifically want the one that is equal to 0. So take your derivative and set your derivative equal to 0 and solve it. So of course this one's simple, divide by 2. Therefore you get x equals 0. So at x equals 0 is where you would have a horizontal tangent line. Now you want the whole point, so to find the y value of the point, you will have to substitute this back into the original equation. Anytime you're finding the whole point, you always have to go back to the original function. Do not go back and substitute into the derivative. So now we would have y is equal to 0 squared plus 1. Therefore you get 1. So that means the point in which you have this horizontal tangent line would be the point 0, 1. Now you could check this in your calculator if you wanted to. Actually, I don't have my calculator here beside me, so I'll just do a rough sketch. But with your calculator, you could just type this into your y equals to check this. But like I said, I'm just going to do a rough sketch here. Okay, so if you graph this in your calculator, this is your parabola that's been shifted up 1 unit. So like you would also have a point here and a point here, and it's the parabola shape. Okay, so what you have figured out is at the point 0, 1, of course this is the point 0, 1, that you would have to have a horizontal tangent line. And since that's the bottom of that valley, that would require for that tangent line for that point to be horizontal. So these points are going to be at the top of hills or at the bottom of valleys typically all of the time. Okay, next one. Still asked to do the same thing. All right, so first of all, we need to start off by finding our derivative. Okay, and again, we're doing horizontal tangent line, so we know that this slope needs to be 0. So of course this represents my slope. So I'm going to set this derivative equal to 0. Now if I solve this for x, first thing I need to do is subtract the 1. And then divide by 3. And then take square root of both sides. Now, when you go to take the square root of both sides, you don't have to worry about doing all the details to complete this, because you're going to take the square root of a negative, which is going to give you imaginary, and that would indicate that you actually don't have any tangent lines that are going to be horizontal. So this would be no horizontal tangent lines is what you're dealing with here. Okay, one more. Of course, this one's got some trig for us to deal with. Again, you're going to start off by taking your derivative. Now, this is just x to the first power, so remember the derivative of this term would be just the coefficient, which is square root 3, plus, okay, now 2 is just a constant multiple here, so you can just do 2 times the derivative of cosine, which is negative sine. So, of course, that's just the same thing as square root 3 minus 2 sine x. So we need to take this and set it equal to 0. Okay, I'm going to subtract my square root 3. And then I need to divide by negative 2. Okay, so I have sine x is equal to square root 3 over 2. Now this is where reference angle is going to come in and help you with this. Your reference angle would have to be 60 degrees, which would be the same thing as pi over 3. Now the interval here, of course, this is in terms of radians, so that's why we also need to do radians down here. But you're just going to consider just one rotation, just from 0 to 2 pi. Now, you have sine equal to a positive. The only place that sine is positive is your first quadrant and your second quadrant. So you need to locate your angles from the first and second quadrant. So from quadrant 1, that would actually just be your reference angle, remember, so that's just pi over 3. But now the second quadrant, if you have a reference angle of 60 degrees in the second quadrant, that's actually 120 degrees, but then you would need to change 120 degrees to radians, which is going to give us 2 pi over 3. So this one is actually going to have 2 places that you have a horizontal tangent line. All right, so these are going to be like our x values for our points. So we've got to get the y value that goes with this and the y value that goes with this. All right, so to complete the ordered pair, remember you got to go back to the original function. So let's start out with x equal pi over 3. So plugging it back into the original. Okay, so this is just going to be square root 3 pi over 3 plus 2 times, now cosine of 60 degrees is 1/2. So of course 2 times 1/2 would just give you 1. So your x coordinate is pi over 3. And your y coordinate, you'll just have to leave it this way as far as an exact answer. And your answer in the textbook may actually get a common denominator here of 3. That would be a possibility, but they're wanting you to leave it exact and not, round it off. Okay, now we need to do the same thing with the 2 pi over 3. So substituting this in. Okay, so this would be 2 square root 3 pi over 3 plus 2 times. Now, your reference angle here is still going to be pi over 3. So you can still use cosine of 60 degrees, which is 1/2, but you're actually going to need to make this a negative 1/2, like where here we were able to keep it positive 1/2 because it's first quadrant, because pi over 3 is in the first quadrant. But remember, 2 pi over 3, if you look back over here, the same thing as 120, that's in the second quadrant, and cosine's negative in the second quadrant. Okay, so you could change this to minus because this is going to end up being a negative 1. So this ordered pair would be 2 pi over 3 for the x value, and then 2 square root 3 pi over 3 minus 1. So this one, like I said, has 2 places in which you have a horizontal tangent line.